Good day, everyone. We are going to show this important proposition in algebra, saying that let V be a vector space of a field F, and let U1, U2 be subspaces of V. Show that U1, if U1 is in U2, then the annihilator of U2 is in the annihilator of U1. But before that, let's first of all define what it means by annihilator. So let U be a vector subspace of a vector space V over a field F. The set of linear transformation, all linear transformation from V to F, such that for all A in U, T of A is equals to 0 of F is called the annihilator of U. That's what we mean by definition. And it's noted U with 0 like this. Yeah. So let's show the first point. So we suppose U1 is in U2. Yeah. This is a subset. U1 is a subset of U2. What are we required to show? We are required to show that U2 annihilator is in U1 annihilator. But we know that U1 being a subset of U2 means for all A element of U1 simply implies that the A is also an element of U2. So we go. To show that a set is a subset, of another set, we take an element T, linear transformation T, element of U2, annihilator. Then we need to show that it's also found in U1 annihilator. But from definition, T element of U2 annihilator means for all B element of U2, comma, T of B is equals to 0 of F. In particular, for all A element of U1 found in U2 from our hypothesis, we have that T of A is equals to 0 of F. So T is an element of annihilator of U1. Hence, U2 annihilator is found in U1 annihilator. Now we can go to the next point, point 2. So point 2 requires us to show that annihilator of the sum of U1 and U2 is equals to the annihilator of U1 intersection annihilator of U2. Okay, we have an equality here. To show that two sets are equal, we must show double inclusion, that this set is contained in this set and that this set is contained also in this set. Okay, we should first do the first inclusion. So we let T be an element of U1 plus U2 annihilator. What are we required to show? We are required to show that I like putting this sentence because it guides me in my work. If I get lost or something like that, I really know what I have to do when I will come back on my steps. So let T be an element of this. Required to show that T is also an element of U1 annihilator intersection U2 annihilator. But what does it mean? This means that what? For all u, I'm going to use some different elements. Yeah. For all a element of u1 and for all b element of u2, t of a should be 0 of f and t of b should be 0 of f, because showing this means t should be an element of the annihilator of u1 and t should be an element of the annihilator of u2. T should be an element of the annihilator of u1 and t should be an element of the annihilator of u2. Yeah, it should be an element of the annihilator of u2. So now this is our idea. This is where we are keeping our main focus. Now let's go. So we go on and say, let our a be an element of u1. What do we observe? We have that a plus the 0 v is equals to a. Yeah, is equals to a, which is an element of u1 plus u2. Since the 0 v belongs to u2, they are subspaces of v. And if they are subspaces, satisfy the property that they contain the null element of v. T of a plus v, since a plus v is an element of u1 plus u2, and t is, from our hypothesis here, t is an element of u1 plus u2 annihilator, work is done. We have it to be 0 of f. Moreover, t of a plus 0 v is equals to t of a. So t of a is equals to 0 of f. What does it mean? T is an element of the annihilator of u1 because a is an arbitrary element of u1. Alright. Similarly, we can let b be an element of u2. Then we are going to get 0v plus b should be equals to, it's an element of u1 plus u2, where the 0 now belongs to u1. Hence we have t of b which is equals to t of b plus 0 of v which is equals to 0 of f, and we can conclude that t is an element of u2 annihilator. We have t element of the of u2 annihilator, t element of u1 annihilator. That simply brings up the definition of the intersection. It is an element of the intersection of the annihilator of u1 and the annihilator of u2. Hence, we can say that u1 plus u2 annihilator is contained in a subset of the intersection of these two. Now, let's show the converse. Yeah, the backward inclusion. So conversely, we let t be an element of annihilator of u1 intersection annihilator of u2, we are required to show here that T is an element of u1 plus u2 annihilator, right? But what does it mean? This means that for every A plus B element of u1 plus u2, A belonging to u1, B belonging to u2. Yeah. Every A plus B, I transform A plus B and get 0 of F. So this is where we are keeping our focus. If we show this, then we are done. All right. So we are going to let our A be an element of u1, our B element of u2. Then we clearly have that T is an element of u1 annihilator and T is an element of u2 annihilator. Because T is an element of the intersection of these two, that means T is an element of u1 annihilator and T is an element of u2 annihilator. I wrote it down here. And T being an element of u1 annihilator means T of A is equal to 0 of F and T of B gives us 0 of F. T of A plus B, T of A plus B, we remember that T is a linear transformation. Yeah, T is a linear transformation. And by the property of linear transformation, I can separate this like this, like so. T of A plus T of B. Yeah. And we know up here that T of A is 0 and T of B is 0 of F. So we're going to have 0 of F plus 0 of F, 0 of the field, which give me 0 of the field. So T of A plus B is equal to 0 of the field. We have that A plus B is an element of u1 plus u2, and they are arbitrary element, and we are seeing that T maps them all to 0 of F. That means T is an element of annihilator, the annihilator of u1 plus u2. Hence we can say that the annihilator of u1 intersection the annihilator of u2 is contained, is a subset of u1 plus u2 annihilator. Hence the equality follow. Yeah, this is where intersection annihilator u2 is equals to u1 plus u2 annihilator. All right, thanks for watching. If you are new to the channel, subscribe and hit the notification bell. Thank you.